Hi, my name is Daniel. I'm a graduate student here at Michigan State, and I'm going to give you a tour of Dr. Lisa Tiemann's lab, where we work on soil ecology and biogeochemistry. So here we go. This is our first part of the lab space, where you can see we have bench areas and a plate reader, as well as chemicals up here. Our plate reader is where we read our enzyme and nitrate assays that we run on different soils. Some more bench space. Part 2. So here we're back in the lab. We've got a sink, a freezer, some more fridges where we store our soil samples. And finally, the sinks where we clean our equipment and our dishes. Now we're passing through to an adjoining room. These are our gas tanks that we use for respiration experiments to study gas fluxes, and a microbalance where we measure tiny amounts of soil. 3. Here we go. Now we're in another adjoining lab area where we have more bench space. We've got some more freezers, a lot more glassware, and a couple of cool machines. Here are some PCR machines where we can study the microorganisms. Alright, so now I've walked down the hallway from the original lab space, and we're going to look quickly at a second lab space, Dr. Jessica Meisel, who is also a soil scientist and also works with fire and biogeochemistry herself. So we can go in here, and you can see it's very similar. A lot of lab space with different instruments, and here is a graduated PhD student, still hard at work. That's it. All right, and finally, I can show you our office space, where a lot of the graduate students did work before we started working from home. That's my office space.
Can you tell us about this equipment in Dr. Olson's lab and what it's typically used for?
Yeah, so this robot we use a lot for normalizing our plates that we send out for either GPS sequencing or we use for running markers. We also have different heads that can do multi-channel for preparing different things and different 384 well plates. There's a ton of different applications that we use, and it's very useful when prepping a lot of samples.
The Cichy lab consists of a food safe lab and a biochemistry lab, which is the lab you're looking at right now. We have equipped a 96 well plate reader. We have sensitive balances, and we have several fume hoods, as well as centrifuges, water baths, pH meters, and freezers that go down to various temperatures. all things necessary to accomplish strong molecular work on dry beans. The hallmark of the CEDU lab is the Matson cookers. The Matson cookers are used to determine the exact cooking times of beans. We place one bean onto this little divot, and as soon as the bean is fully cooked, the pin will drop through the bean, and this machine will help record its cooking time on these computers. We specialize in black beans as seen here, cranberry beans, navy beans, yellow beans, and brown beans from all different parts of the world. Here we test the hardness of the beans. We can also determine what color they are using this lab scanner, and much more. Here's a photo box that we use to take photos of the beans, and a mill, which we use to process the samples into flour for nutrient content analysis and other things like GBS sequencing. Autoclaves on the 3rd and 5th floor. On the 3rd floor there are 4 autoclaves. You're capable of reserving an autoclave for your lab. You can autoclave liquids and solids, and you can also change the temperature and duration of the autoclave, so it's fully customizable. We have the growth chambers as well in this building, and they can be customized however you would like. Just ask Jim Plug. He can change the moisture content, the temperature, the amount of light. I've even had situations where I needed a computer to be hooked up right in front of this particular machine, and so he gave me an extension cord and I was able to use it right there. This is for very controlled experiments. This is the greenhouse. If you take greenhouse training, then you also will be able to access it. Our greenhouses are equipped with lighting that is specialized for plant growth. It's a mixture of red with a gentle splash of blue. Here you can see some beans growing. And people do this for all kinds of purposes, including breeding, advanced generations, and for testing of disease resistance. Here's an interesting project. Beans here are growing in rhizotrons. They're growing at a 45-degree angle, and because they're clear on one side, you'll be able to see the roots growing from that side. Otherwise, most people choose pots. Here on Hope Road is the Crop and Soil Science Teaching and Research Agronomy Farm. Here's the building over there where all the good magic happens. Over here is the turf grass facility, which is where we study very short grasses that cover surfaces like golf courses. Activities here on the agronomy farm consist of planting, harvesting, seed sorting, counting. A lot of the harvesting, of course, takes place in the fields surrounding the agronomy research farm. And then over here in these buildings, seeds are counted, cleaned, threshed, and finally put into bags and analyzed for further scientific research. Most of the seeds are processed here in this part of the facility. Seeds are dried here in these devices, which dry the seeds, or on those racks over there. Potatoes are tested for quality at this sorting machine. And there's also a small room over in that direction where potato chips are made from the potatoes and then tested. They'll often be stored in bins like this. Workshop where tractors are maintained. Over there leads to the greenhouses at the agronomy farm. Here's an example of seeds from the field. These are soybeans. They'll later be stored in little packets like this. Seed counting often takes place in this room. Here we can see some soybeans. That's what they look like, if you didn't know. And here we have some cans of dry beans that will later be evaluated for quality testing. Labels can be printed in preparation for the next harvest season. Seeds of all varieties, corn, wheat, soybean, dry beans, will then be stored at cold temperatures in this large storage facility. This is, of course, all MSU property. So in summary, that is what CSS is. 5 stories of absolute beauty. And of course, we have lots of other buildings that you can take advantage of too, such as the Center for Advanced Microscopy. And we also have plant pathology attached to us as well. I've worked with people from there as well as from people in horticulture. We look forward to seeing you in person. Thank you so much. And we're looking forward to a better year.